Now let's go to second quadrant, second case. We are talking about sine theta. How values of sine theta are changing as theta is changing. That's what we are talking about. How values of sine theta are changing as theta is changing. Now let's take theta between 90 degrees and 180 degrees in the second quadrant of this unit circle. So between 90 degrees and 180 degrees, let's draw a right angled triangle in the second quadrant of the circle. This is the circle. Let me draw x-axis and also y-axis. This is the origin of the coordinate system, which is also center of the circle. Let's take a right angled triangle in the second quadrant. The hypotenuse of the right angled triangle is making an angle theta with positive x-axis. This angle theta is greater than 90 degrees. Look at this angle. This angle theta is greater than 90 degrees. Let me say this angle is alpha. The other angle in the right angled triangle is beta. Of course, the horizontal side is x, but x is negative here. X is measured along the negative x-axis. Y is measured above x-axis. Above x-axis means positive y. So in the second quadrant, x value is negative, y value is positive, and r is of course root of x square plus y square. Use Pythagoras theorem. Hypotenuse square is equal to sum of the squares of the sides. Well, look at the value of sine theta. Here sine theta is equal to opposite side by hypotenuse. Sine theta is equal to opposite side by hypotenuse. Opposite to angle theta, the side is y-axis. Sorry, the side y. AB is the side opposite to theta. Y is positive. So the ratio sine theta is positive. We write sine theta is equal to y divided by r. Y is positive, r is positive, so sine theta is positive. So in the second quadrant, sine theta, the value of sine theta is positive. You are going to get a positive value for sine theta. But as theta increases, what happens to the value of y? To know that, draw one more right angled triangle. Look, here theta has increased, but look at the value of y, opposite side has decreased. Draw one more right angled triangle. Y has decreased further. Draw one more right angled triangle with greater than angle before. So y is decreasing. It means as theta is increasing, the opposite side is decreasing. As theta increases, the opposite side y decreases. Y is decreasing. So sine theta is positive but decreasing. Sin theta value is positive but is decreasing as theta is increasing. You know, sin 90 degrees is equal to 1. That is one extreme in this quadrant. The lowest limit of this quadrant is 90 degrees. So, but as theta approaches 180 degrees, look, this angle is very close to 180 degrees. Look at this theta here. This theta is very close to 180 degrees. So, as theta approaches 180 degrees, y value is approaching 0. So, draw one more right angle triangle with angle theta close to 180 degrees. Draw one more right angle triangle with the angle theta close to 180 degrees. Look at the value of y here. What is happening to the value of y? Y is decreasing. So for theta is equal to 180 degrees, y value becomes 0. So if theta is equal to 180 degrees, the value of y becomes 0. For theta is equal to 180 degrees, y becomes 0. It means opposite side value becomes 0. It means sin theta becomes 0. So what we understand now here is that from 90 degrees to 180 degrees, when theta increases from 90 degrees to 180 degrees, sin theta value decreases from 1 to 0. That's the conclusion we come to. So I am going to write down that conclusion here. As theta increases from 90 degrees to 180 degrees, sin theta is positive but decreases from 1 to 0. Its value is decreasing from 1 to 0. So this is one conclusion that we come to. Also, now look at alpha and beta. Here, look at angle B. Angle B is beta. This is its alternate angle. So this angle is also beta. These two are parallel lines, y-axis and the vertical side of the right angle triangle are parallel lines. With those parallel lines, this OB makes equal angles. This angle is beta. This angle is alternate angle, so that's also beta. Now look at the figure. If you look at the figure, this angle is how much? 90 degrees, of course. Angle between x and y axis is 90 degrees. Can I say theta is equal to 90 degrees plus beta? Theta, look at theta. Theta is equal to 90 degrees plus beta. And look at theta and alpha. Theta plus alpha is equal to 180 degrees. So in the figure, we can write theta plus alpha is equal to 180 degrees, or I can write theta is equal to 180 degrees minus alpha. Also, theta is equal to 90 degrees plus beta. Theta is equal to 90 degrees plus beta. So this is the relation between angles theta, alpha and beta in the figure. Now, look at sin alpha. Look at the right angle triangle. Sin alpha is equal to opposite side by hypotenuse. So sin alpha is equal to y by r. Look at cos beta. Cos beta is also equal to y by r. Y is the adjacent side of angle beta. Since y is the adjacent side of angle beta, we can write cos beta is equal to y by r. We also got sin theta is equal to y by r. We know sin theta is equal to y by r. Call this equation number 1. Theta is equal to 180 degrees minus alpha. Call this equation number 2. Theta is also equal to 90 degrees plus beta. Call this equation number 3. and sin alpha is equal to y by r, call this equation number 4. Cos beta is equal to y by r, call this equation Roman number 5. Now from these 5 equations, or look at only first equation, second equation and fourth equation. So from first, second and fourth, what is the conclusion I come to? Here I am going to substitute second equation in the first equation. So in place of theta I am going to write 180 degrees minus alpha. Sin 180 degrees minus alpha is equal to y by r, because theta is 180 degrees minus alpha. Sin 180 degrees minus alpha is equal to y by r. Sin alpha is also equal to y by r. It means sin 180 degrees minus alpha is equal to sin alpha. Okay, this is one more trigonometric identity. In the previous page, we wrote one trigonometric identity, you remember? Look, sin 90 degrees minus theta is equal to cos theta. This is what we wrote in the first quadrant. And in the second quadrant, sin 180 degrees minus alpha is equal to sin alpha. Similarly, theta is also 90 degrees plus beta. So substitute 90 degrees plus beta in the first equation. So sin 90 degrees plus beta is equal to y by r. Cos beta is also equal to y by r. It means, so from first equation, third equation and fifth equation, we can write sin 90 degrees plus beta is equal to cos beta. Okay, so these are the two other identities, trigonometry. Okay, so these are the two equations that we write in the second quadrant. Sin 180 degrees minus alpha is equal to plus sin alpha. Sin 90 degrees plus beta is equal to cos beta. So sin theta is greater than 90 degrees here. Theta is greater than 90 degrees here, but less than 180 degrees. So in the second quadrant, sin theta should be a positive value. Sin theta should be a positive value. So that is why we are getting here plus sin alpha for sin 180 degrees minus alpha and plus cos beta for sin 90 degrees plus beta. So these are the conclusions that we come to in the second quadrant. So in the second quadrant, as theta increases from 90 degrees to 180 degrees, sin theta is positive but decreases from 1 to 0. And sin 180 degrees minus alpha, theta, whatever the name that you give, sin 180 degrees minus alpha is equal to sin alpha, sin 90 degrees plus beta is equal to cos beta. Let's look at third quadrant. So in the third quadrant, again, we are going to study how sin theta is changing as theta is changing. Third quadrant means between 180 degrees and 270 degrees. Theta, as theta changes from 180 degrees to 270 degrees. So how is sin theta changing? That's what we are going to study. The coordinate system. This is the center of the circle. Now let's draw right angled triangle in the third quadrant of the circle. Let's look at this right angled triangle. In this right angled triangle, angle made by the hypotenuse of the right angled triangle with positive x-axis is theta. This theta, of course, is greater than 180 degrees and less than 270 degrees. Let me say the angles inside the right angled triangle are alpha and beta. Let me call this angle alpha and this angle by the name beta. Let's also give the names to these vertices A, B. OA is equal to x, AB is equal to y. Now look at the horizontal side of the right angled triangle. It's measured along negative x-axis. So OA is negative, x is negative. Y is measured below x-axis. So y is also negative, AB is also negative. Here x the side OA, x is negative, or the side A and the side AB or y is also negative, x negative, y negative. The hypotenuse is equal to r. Now sine theta here, sine theta is equal to y by r, but y is negative and r is also negative. Sine theta, if I take modulus, I mean only magnitude of y and substitute it here, so we are getting negative value here. This is negative. So this is for theta lying between 180 degrees and 270 degrees. For any angle between 180 degrees and 270 degrees, sine theta value is negative. We know already sine 180 degrees is equal to 0. We have seen in the second quadrant. In the second quadrant, sine theta value approaches from 1 to 0. Sine theta value decreases from 1 to 0. Sine 180 degrees is equal to 0. As theta increases, look at the value of y. Y becomes, so y becomes equal to minus r then. So for theta is equal to 270 degrees, y becomes equal to minus r. I will write for theta is equal to 270 degrees, y is equal to minus r. So in that case, our y becomes r because we are only writing the magnitude here, modulus of y. So modulus of y is equal to r. Modulus of y is equal to r. Magnitude of y is equal to r. Substitute magnitude of y here, you will get sine theta is equal to minus 1. So as you can see, when theta increases from 180 degrees to 270 degrees, sine theta decreases from 0. It's not decrease, it's just ratio of sides, so it can't be decrease. This is just the number 0, it's not 0 degrees. So as theta increases from 180 degrees to 270 degrees, sine theta decreases from 0 to minus 1. That's one conclusion that we come to. Sine theta is negative and its value is decreasing from 0 to minus 1. So between theta is equal to 180 degrees and theta is equal to 270 degrees, or in the third quadrant. So the conclusion that we come to is that the value of sine theta is negative and decreases from 0 to minus 1. The value of sine theta decreases from 0 to minus 1. Now let's write down the relation between theta, alpha and beta. Look at the figure. This angle is beta again. The angle B and this angle are alternate angles. These vertical sides, y-axis and vertical side of rectangular triangle are parallel sides. So this line makes equal angles here. Okay, so this angle is beta. Look at the figure. You can write theta is equal to 180 degrees plus alpha. 180 degrees, this angle is 180 degrees plus alpha is theta. And you can also write, since this angle is 270 degrees, theta plus beta, you can see theta plus beta is equal to 270 degrees. So look at the figure, theta plus beta is equal to 270 degrees, or I can write theta is equal to 270 degrees minus beta. This is a relation between theta and beta. Write sine alpha and sine beta values, not sine beta. Y by r. We want y by r. Sine alpha is equal to y by r. Cos beta is equal to y by r. Look at the figure. Y is opposite side to angle alpha, but adjacent side to angle beta. So cos beta is equal to adjacent side by hypotenuse. Sin alpha is equal to opposite side by hypotenuse. Okay. So here we can write, look at these equations. Just like we did in the previous case, look at these equations. First equation, second equation, third equation, fourth, and fifth. So from these equations, what are the conclusions that we can come to? From equation 1, 2, and 4, we can write from equations 1, 2, and 4, we can write sine 180 degrees plus alpha is equal to minus sine alpha. This is modulus of y by r, modulus of y by r, magnitude of y by r in a right angle triangle. Alpha is an acute angle, so it has to be positive. Sine alpha has to be positive, cos beta has to be positive. So sine 180 degrees plus alpha is equal to minus sine alpha. How? Substitute theta is equal to 180 degrees plus alpha here. Substitute second equation in the first one. So what do you get? Sine 180 degrees plus alpha is equal to minus y by r. Y by r means what? Sine alpha. So sine 180 degrees plus alpha is equal to minus sine alpha. And from equations 1, 3, and 5. Look at these three equations. So substitute 3 in the first equation. You will get theta. Substitute theta is equal to 270 degrees minus beta here. So sine 270 degrees minus beta is equal to minus y by r, which means minus cos beta. So sine 270 degrees minus beta is equal to minus cos beta. So these are two other trigonometric identities. We called, look at the previous page. In the previous page, that is third equation. So here, this has to be fourth identity. This one is 5. So in the third quadrant, the conclusions that we have come to. Okay, we don't have to memorize or mug up anything. These are all logical conclusions. Mathematical logic. We follow mathematical logic. We don't memorize or mug up anything. In the third quadrant, sine theta is negative and decreases from 0 to -1. That's the first conclusion that we come to. And the second conclusion is these relations. Okay, now let's go to fourth quadrant. So we are going to study how the values of sine theta change as theta changes from 270 degrees to 360 degrees. As theta changes from 270 degrees to 360 degrees, we are going to study how sine theta changes. Just like we did in the previous three cases, draw a circle here. Let's also draw x and y axis passing through center of the circle. Origin is at center of the circle. Center of the circle is at O. Let's draw a right angled triangle in fourth quadrant. Look at this right angled triangle. OAB. Here x is on the positive side of x-axis. I mean the side OA is on the positive side of x-axis. The side AB is below x-axis. It means on the negative side of y-axis. Y is on the negative side of y-axis, AB. Alright, if you look at angle made by the hypotenuse of the triangle with positive x-axis is theta, and that theta is greater than 270 degrees and less than 360 degrees. Just like we called these angles previously alpha and beta, here also let's call this angle alpha and the other angle in the right angled triangle beta. This angle is also beta, you know why. Alternate angles. Now, in the fourth quadrant, y is negative. So you will get sine theta is equal to minus y by r. Y is negative because it's on the negative side of y-axis, below x-axis. So sine theta is negative. We know sine 270 degrees. In the previous case, we found that sine 270 degrees is equal to minus 1. Sine 270 degrees is equal to minus 1. Sine 360 degrees, if you find, 360 degrees means full circle. So in a full circle, if you keep, increasing angle theta, or if you keep decreasing angle alpha, increasing angle theta means decreasing alpha. Alpha is decreasing. Alpha is decreasing. So what is happening to opposite side? Y. Y is decreasing. As alpha decreases or as theta increases from 270 degrees to 360 degrees, Y is decreasing. When theta becomes equal to 360 degrees, Y becomes equal to 0. This side becomes equal to 0. When theta becomes equal to 360 degrees. So, for theta is equal to 360 degrees, the conclusion that we come to, 360 degrees also means 0 degrees. For theta is equal to 360 degrees, the conclusion that we come to is that opposite side y becomes 0. So, for theta is equal to 360 degrees, y is equal to 0. Opposite side is equal to 0. It means sine 360 degrees is equal to 0. So So what is happening in the fourth quadrant? Sin theta value increases from -1 to 0. Sin theta value increases from -1 to 0. That's the first conclusion that we come to. So as theta increases from 270 degrees to 360 degrees, between theta is equal to 270 degrees and 360 degrees, sin theta is negative and increases its value from -1 to 0. Sin theta value increases from -1 to 0. Let's also write down the relation between theta, alpha and beta. Well, if you look at the figure, you can understand that theta plus alpha is equal to 360 degrees, or theta is equal to 360 degrees minus alpha, and theta is equal to 270 degrees plus beta. This angle is 270 degrees. So 270 degrees plus beta is equal to theta. So theta is equal to 270 degrees plus beta. Well, look at y by r in the figure. In the figure, this is r. Look at y by r. Y by r can be either equal to sin alpha and cos or cos beta. Sin alpha is equal to opposite side by hypotenuse, y by r. Cos beta is equal to adjacent side by hypotenuse. Adjacent side to beta is y. Cos beta is equal to y by r. Sin alpha is also equal to y by r. So from these equations, again, let me call this equation 1. Here is second one, the third one, fourth one, and fifth one. So from these 5 equations, I can write from 1, 2, 3, 4, and 5. We can write sin 360 degrees minus alpha is alpha, and sin 270 degrees plus beta is equal to minus cos beta. These are the 2 more identities that we can write. What is its number? This is 5, so in the next page it is 6 and 7. So this is what happens in one cycle. In one cycle, the total angle is 360 degrees. So what did we do in these 4 cases? We changed angle theta from 0 degrees to 360 degrees and studied how sin theta values change. Okay. If theta is greater than 360 degrees means second cycle. Same thing happens. So for theta greater than 360 degrees, you will again land in first quadrant. In the first quadrant, 0 to 90 degrees, 90 to 180, 180 to 270, 270 to 360. So greater than 360 means again first quadrant, second cycle. Okay, so this is 360 degrees plus 90 degrees. This is 360 degrees plus 180 degrees. This is 360 degrees plus 270 degrees. I am talking about the second cycle. Now 360 degrees plus 360 degrees, 2 cycles complete. Third cycle, 360 plus 360, which is 720. 720 plus 90, 720 plus 180, 720 plus 270, 720 plus 360, 3 cycles completed. So same thing repeats after every 360 degrees. Conclusions at one place. In the first case, as theta increases from 0 degrees to 90 degrees, sine theta, the value of sine theta changes from 0 to 1. So between 0 degrees and 90 degrees, theta increases, sine theta also increases from 0 to 1. Well, sine 90 degrees minus theta is equal to cos theta. In the second quadrant, as theta increases from 90 degrees to 270 degrees, sine theta is decreasing from 1 to 0. So in the second quadrant, sine 90 degrees plus theta is equal to cos theta, theta, alpha, beta, whatever the name that you put, but this equation is always true. Sine 90 degrees plus theta is equal to cos theta, and sine 180 degrees minus theta is equal to plus sine theta, plus cos theta plus sine theta. And in the third case, as theta increases from 270 degrees to 360 degrees, what is happening to sine theta? Sine theta is decreasing from 0 to minus 1. Theta is decreasing from 0 to minus 1. So here again, if you write down the identities, in the third quadrant, sine 180 degrees plus theta is equal to minus sine theta. Sine 270 degrees minus theta is equal to minus cos theta. Next, in the fourth quadrant, we made a mistake. This is 90 degrees to 180 degrees, and here is the third quadrant is 180 degrees to 360 degrees. Degrees to 270 degrees. Okay. Now fourth quadrant is 270 degrees to 360 degrees. So theta changes from minus 1 to 0. Theta, the sine theta increases from minus 1 to 0. Okay. Here again, the identities that we write are sine 270 degrees plus theta is equal to minus cos theta. Sine 360 degrees minus theta is equal to minus sine theta. So sine theta values are positive in the first quadrant and in the second quadrant. Sine theta values are negative in the third quadrant and in the fourth quadrant. Okay. Sine theta increases in the first quadrant. The values of sine theta increase in the first quadrant. Sine theta value decreases in the second quadrant, decreases in the third quadrant, and increases in the fourth quadrant. Okay, these are the conclusions that we can come to. If I draw a graph showing how sine theta is changing as theta is changing, Let me draw graph between sine theta and theta. I'll take sine theta. The graph shows the variation of sine theta and theta. Let me say this is x-axis. And here is y-axis. On y-axis, I'll take the values of sine theta, and on x-axis, I'll take the values of theta. So we are studying graphically how sine theta is changing as theta is changing. So take theta on x-axis and sine theta on y-axis. Let's take two values. Let's take one value here. Sine 0 degrees is equal to 0 degrees. It means when theta is equal to 0 degrees, sine theta is equal to also 0 degrees. So the graph passes through origin. Theta is x, sine theta is y. Let us say theta is x, sine theta is y. When theta is 0 degrees, that means x is equal to 0 degrees. Sine theta value is also 0. It means y is equal to 0. So x is equal to 0, y is equal to 0. When theta is equal to 90 degrees, the value of sine theta is equal to plus 1. So for theta is equal to 90 degrees, sine theta value is equal to 1. For theta is equal to 180 degrees, again sine theta is equal to 0. When theta is equal to 180 degrees, when x becomes 180 degrees, y becomes 0. So 180 degrees comma 0 point here. This point is 90 degrees comma 1. This point is 0 comma 0. Again, when theta becomes 270 degrees, sine theta value becomes minus 1. Let's say this is minus 1 line. This is 270 degrees. So for 270 degrees, sine theta value is equal to minus 1. So this point lies here. X is equal to 270 degrees, y is equal to minus 1. Next, when theta becomes 360 degrees, y becomes 0. So the point lies somewhere here. When theta is equal to 360 degrees, y becomes 0. Okay, or sine theta becomes 0. Now let us draw the graph. Well, if you draw a graph here from 0 to 90 degrees, sine theta increases. From 90 degrees to 180 degrees, sine theta decreases. From 0 to 90 degrees, sine theta increases. From 90 degrees to 180 degrees, sine theta decreases. So this is in the first quadrant. The second part of this green line is in the second quadrant. So here, from 0 to 190 degrees, sine theta increases from 0 to 1. From 90 degrees to 180 degrees, sine theta decreases from 1 to 0. It's positive. In both quadrants, the values of sine theta are positive. From 180 degrees to 270 degrees, sine theta value decreases from 0 to minus 1. The graph comes like this. From 180 degrees to 270 degrees, sine theta decreases from 0 to minus 1. From 270 degrees to 360 degrees, sine theta value increases from minus 1 to 0. So this is the shape of the graph. Why is the graph not a straight line? Why is it a curve? What type of curve it is? That we will discuss when we discuss graphs. So this is how sine theta changes as theta changes.